All right, everyone, we are on our last problem, creep, creep, creep. Let's look at the following stress strain curves below. Draw, describe the deformation mechanism for the three curves, describe which regions are changing, label all sections of deformation mechanism maps. So in our maps, we know, well, actually, let's talk about a couple things. So for my blue and for my red, those can be the same material that have been either work hardened, so my yield stress scales as dislocation density to the 1/2 power, or they've been grain size strengthened and my yield stress scales as dg to the -1. When I compare these to the green curve must have, if they were all the same material, it had to be solute strengthened. So my scales as C solute to the 1/2 power, to the 1/2 power, or it was precipitate hardened. Because why do we know this? Well, we know that because slope changes, so we must have changed essentially the material chemically. If we look at, generally speaking, our deformation mechanism map, so stress derivative G, homogeneous temperature. Let's say all these materials have the same, or every one of material has the same theoretical yield stress. If I'm ranking this, we know that our yield stress of green is greater than my yield stress of blue, which is greater than my yield stress of red. So the red would be the lowest. So I'm going to say this is my red. This is my blue. And this is my green. Now, if I'm looking at my red, so let's say this is my PLC will look the same. So PLC is exactly the same. My Nabarro Herring will probably be the same. But the only difference is for my blue curve, if I was work hardening it, I'm going to have a larger, my Koebel creep of blue is going to be larger than my Koebel creep of red. Now, that's the big difference there. So you can kind of draw that out or kind of explain that out. Now, if I'm comparing my blue and my red to my green curve, it kind of depends on what was the starting material state. But basically, there's not going to be, when I do the green strengthening mechanism, it will not change the Koebel creep region at all. So it'll be exactly the same. Excellent. So that's fine. For my yield stress, we've ranked them. Grain size, so that means my grain size of, I know for sure my grain size of blue is smaller than my grain size of red. And we're not really sure about the other one. Solute concentration, I know my concentration of solute for my green curve is greater than that of my B, which is probably equal. My blue and red are probably the same. Must be the same, actually. Excellent. So we've talked about that. We've talked about this. Why does PLC dominate higher stress than Koebel creep? Well, we know that it scales as stress to the 4 to the 6 power. And that's it. So, see you in the next video. Thanks. Bye.